We're going to spend some time talking about the parabola. We're probably most familiar with the parabola being the graph that results with a quadratic function. We're going to look at a parabola kind of as a geometric figure, derive what that equation should look like. And a geometric definition of a parabola is a set of points that are equidistant from a given line, which we call the directrix, and a given fixed point, which we call the focus. The point that's halfway between the focus and directrix is called the vertex. It is the nose of the parabola. And the line perpendicular to the directrix that goes through the vertex is called the axis, or the axis of symmetry. So here's what we start out with, right? So our directrix, if I want a parabola, the first thing I need is a directrix. That's this line here. We're going to start out, by the way, with parabolas that have their vertex at the origin, and we'll move it around later on. But we're gonna focus on that first. So you fix this line, we call it the directrix, and this point here, this is the focus. Now, what makes a point on the parabola? So let's say I take this point right here. Right, there's our point P as coordinates x, y. What makes it on the parabola is that the distance to the line, which is always a straight line distance, the shortest distance, a perpendicular distance, is equal to the distance to the focus. So these two line segments in red are the same distance. That's what makes P a point on the parabola. So the distance from the point P to the directrix is P plus X, or X plus P. The distance from the point P to the focus we can get just by using the distance formula, and that's what we see here. So this is the square root of X minus P squared plus Y minus 0 squared. The focus is on, if the vertex is at the origin, then the focus is on the x-axis. So that's why it has coordinates P0. And the focus and the directrix, the vertex is always halfway in between. So if the focus has coordinates P0, then the directrix is going to be at x equals negative P, right? These distances have to be equal to each other. So we get this equation, and now let's simplify it. And I guess what we could do to simplify first is square both sides and get rid of that radical. I'm going to do a couple of things at once. So we've got, on the left side, I've got x plus p squared. I'm going to expand that. So x squared plus 2px plus p squared. On the other side, I'm going to expand the x minus p squared, so that's x squared minus 2px plus p squared, and then plus y minus 0 squared is y squared, and we've squared it so there's no radical. I'm going to isolate the y squared terms, so I'm going to subtract x squared from both sides. I'm going to add 2px to both sides. And I'm going to subtract p squared from both sides. Now what we have left on the left side is 4px, and what we have left on the right side is y squared. This is the standard form of a parabola that's oriented horizontally. So you'll notice, it's got its vertex at the origin, and it opens to the right. This is the standard form for a parabola that opens to the right or to the left, that has its vertex at the origin. Let's do some examples. In this standard form, what's good to observe is that if we have a parabola in standard form with the vertex at the origin, then based on what the coefficient of x is, I could tell what the value of p is, so I know how far out from the vertex I'm going to go to get the focus and the directrix. So we're going to find the focus and directrix of the parabola y squared equals 12x. So if y squared equals 12x is our parabola, then note that 4p is equal to 12, and that means p is equal to 3. It's a positive 3. So look, if the value of p is positive, that means that the focus has a positive x coordinate, and it opens to the right. So our focus is the point 3, 0, and that means the directrix is 3 units in the opposite direction. The directrix is the line x equals negative 3. So then they ask us to sketch it. So here's the focus. Here's the directrix. If we're sketching a parabola, we should include the focus and directrix. Those are the things that define the parabola itself. We know that the vertex is at the origin, because in the beginning, for all of these, our vertex is at the origin. And then we know it opens to the right. Now you can make it a little bit more accurate if you want, and that is you could do so by just finding another point or two. So like if x is equal to 3, there's going to be 2 different y coordinates. There's going to be one positive and one negative. Then y squared is 12 times 3, which is 36, and that means y is plus or minus 6. So there's our parabola. In our next example, we're going to do the same thing. They give us the equation y squared equals negative 8x. And looking at this equation, it's in standard form, so I know that 4p is equal to negative 8, and that means that p is equal to negative 2. So p is negative, right? So the focus is going to be negative 2, 0. That means it's going to open to the left. And that's generally true if you have a horizontally oriented parabola, regardless of where the vertex is. If p is negative, it opens to the left. And our directrix is the line x equals positive 2. Then we're going to sketch it. There's our focus, there's our vertex, and our directrix. So I know that it opens to the left. The parabola is always going to open away from the directrix and kind of swallow up the focus. And we can make our sketch a little bit more accurate if we get a couple more points. Let's say if x is equal to negative 2, we'll get a couple of y coordinates. Then y squared is negative 8 times negative 2, which is 16, and that means y is plus or minus 4. So far we've been looking at parabolas that are oriented horizontally. We can have parabolas that are oriented vertically, that open up or down. And the standard form for that parabola, if the vertex is at the origin, is just x squared equals 4py. So we've just sort of reversed the roles of x and y there, right? So if it's oriented horizontally, it's y squared equals 4px. If it's oriented vertically, it's x squared equals 4py. If we could do a similar example as we did before, they gave us the equation x squared equals 4y. We can find the focus and directrix. Now this time the focus is on the y-axis and the directrix is a horizontal line, so it'll have an equation of y equals some constant. So our equation is x squared equals 4y. So this means that 4p is equal to 4 and p is equal to 1. So our focus is the point 0, 1, because it's on the y-axis, and the directrix is the line y equals -1. We can sketch this one. There's our focus. There's our vertex. Here's our directrix. And it opens upward, because it always opens away from the directrix and swallows up the focus. If we want, we can make our sketch a little bit more accurate. We could say, well, you know, what if y is equal to 1? We'll get a couple of x coordinates. Then x squared is 4 times 1, which is 4, and that means x is plus or minus 2. And we have a parabola that looks roughly like that. Let's do one more of these. We're going to find the focus and directrix of this parabola. Now, the first thing we should observe is it is not quite in standard form right now. Oops. It's not in standard form because I've got that coefficient of 2 on the x squared. So the standard form is x squared equals 4py. So we want to get rid of that coefficient of 2. We'll just divide. I have -9/2 y. So looking at this, now it's in standard form, so I know that -9/2, that's equal to 4p. And dividing by 4 tells us that p is -9/8. And I know it's oriented vertically because it's x squared, and p is a -9/8, so that means that the focus is 0, -9/8. And the directrix is y equals positive 9/8. That means this parabola opens downward. It's got a -9/8 focus. So -9/8 would be just a little bit less than -1. The directrix is a positive 9/8, so that's just a little bit above +1. I know that the vertex is at the origin, and it opens downward. Alright, so far what we've done is they've given us equations, and we've gleaned some geometric information. We're able to find focus and directrix put a little sketch together. Now we're going to go the other way around. And here's an example where they're telling us right off the bat that the vertex is not at the origin. But they want us to use the definition of the parabola to find the equation of the parabola with the focus 2, 3, and directrix y equals -1. So when they say definition of the parabola, they mean going back here, and noting that what makes a point on the parabola is that its distance to the directrix is equal to the distance to the focus. They start off by giving us some geometric information. I know the focus and I know the directrix. So I'm going to start by just plotting those things and then trying to infer some other information about this parabola. So the focus is at 2, 3. And the directrix is y equals -1. So right off I could tell that this is oriented vertically. It's got a horizontal directrix, so it's going to open upward because the parabola always kind of swallows up the focus. I know that the vertex will be halfway in between the focus and the directrix on that dotted line, on that axis of symmetry there. And so if this is y equals -1 and this focus is up at y equals 3, that's a total distance of 4, and halfway there we'll put the vertex right here at 2, 1. Okay, so far I've got the vertex. That's what I've figured out. And I'm going to just go ahead and sketch this. I'm going to sketch it because it's going to help me kind of visualize what I need to do. It's maybe not the best sketch, but it'll work in a pinch. So I'm going to take a point. I'm going to say, suppose I know that this point, xy, is on the parabola. What makes it on the parabola, again, I'm using the definition of the parabola, and what makes it on the parabola is that this distance is the same as this distance, even though I didn't draw it so it looks exactly the same, but like that's what makes it on the parabola. Those distances have to be the same. Now this vertical distance will be pretty easy to figure out because it's top y minus bottom y. I know the bottom y is -1, so this distance is y plus 1, right? The top y is just y. This distance here, I'm going to use the distance formula. And now I have enough to put together the beginnings of an equation. So if xy is on the parabola, then the equation, the distance y plus 1 must be equal to that other distance. So the distance formula is, let's see, x2 minus x1 squared. So x minus 2 squared, difference in x's squared, plus difference in y squared, y minus 3 squared. There's the beginnings of an equation. I'd like to simplify it so it looks a little bit nicer. I will square both sides. I'm going to FOIL out or expand out the square on the left, so y plus 1 squared is y squared plus 2y plus 1. On the right side, I'm squaring, so I've gotten rid of the radical, and then I'm going to expand both of those squares. So we have x squared minus 4x plus 4, and then plus y squared minus 6y plus 9. I'm going to get all of my y's on one side and everything else on the other side. So I'm going to subtract y squared, subtract y squared. I'm going to get my y's on the left side. Plus 6y plus 6y, and then I'm going to subtract 1 to get all my constants on the other side. So now what we have is 8y on the left. On the other side here, I've got x squared minus 4x, and then, let's see, 4 plus 9 is 13, minus 1 is plus 12. And I can actually just solve for y. If we divide both sides by 8, y is equal to, say, 1/8 times x squared minus 4x plus 12. So, you know, this isn't a standard form, but it is at least something where I could, produce some y coordinates given some x coordinates, or I could throw it into the calculator. There it is, where y is written as a function of x. But it is not in standard form. It'd be nice if we could get it into a standard form. You know, when we look at this equation that we have right here, it is not obvious that that parabola has focus 2, 3 in Directrix y equals -1. It's not obvious looking at that parabola that the vertex is 2, 1. And that's information we could get, we could figure out, but it's not immediately obvious. So there is a nice standard form for the equation of a vertex, even if, for the equation of a parabola, even if the vertex isn't at the origin. And so what we do is we take our basic two, for the vertex at the origin, right? Our standard forms are y squared equals 4px and x squared equals 4py. If our vertex is anywhere else, if the vertex is at the point hk, all I do is replace y with y minus k and x with x minus h. And then whichever variable is squared, that depends on whether it's oriented vertically or horizontally. So if the axis is horizontal, if it opens to the left or to the right, it's the y minus k squared equals 4p times x minus h, and if it opens up or down, it's the x minus h that's squared by itself. So in example 120, it's similar to the last one, only they don't say use the definition. They say just find the equation of a parabola with vertex 2, 4 and focus 4, 4. So they're not asking us to use a definition and set some distances equal. They're giving us information. When they start out by giving us geometric information, I often begin by just sketching it. So the vertex is 2, 4. And the focus is 4, 4. Okay. Now, what we've known for a while now is that when we were working with parabolas that have their vertex at the origin, that the value p gave us the actual coordinate of the focus. Now, if our vertex is not at the origin, that's no longer true, but p always gives you the directed distance from the vertex to the focus. So in this one, p is equal to 2, right? The last one that we did. In this example, p is also equal to 2, positive 2. I could see that it opens to the right, so p is positive. I know it's going to look something like this. And it opens horizontally. So I know I'm going to start out with the form y minus k squared equals 4p x minus h. From the sketch, I could tell that P is equal to 2, so I could put that in, and they told me the vertex, 2, 4, so that's H, N, K. So I have y minus 4 squared equals 4 times 2, x minus 2. And then that's my standard form. Y minus 4 squared equals 8 times x minus 2. So the standard form is super convenient for the same reason that the standard form is convenient for the circle, right? There's geometric information we can glean from it immediately. We kind of can get a picture of it pretty quickly without needing to plot too many points. If we are starting with the equation of a parabola that's not in standard form, we can get it in standard form by completing the square. Now, when we're looking at a parabola, we could tell it's a parabola because one variable is squared and the other is not. Here I've got an x squared, y is not squared. So I only have to complete the variable, or complete the square on one variable, right? And we're going to start out by getting the x squared and x by itself and moving the y and the constant term over. So I've got 2x squared minus 4x equals, what, 9y plus 16. Now I want to complete the square on just plain old 1x squared, not 2x squared, so I'm going to divide through by 2. So I get x squared minus 2x, and I'm going to leave room for the magic. And then on the other side I got 9 halves y plus 8. Now we can complete the square on x. The coefficient on x is -2. Cut that in half and square it. So I'm going to add the square of -1 to both sides. This on the left side is now a perfect square. It is the square of x minus 1. And over here I've got 9 halves y plus 9. Okay, now we are almost in standard form, not quite in standard form, because what I want is for the right side to look like 4p y minus k, right? So that's not quite there. And what I'm going to do is just factor out the 9 halves. So when I factor out the 9 halves, let's see, what value is going to go there, so that when I distribute 9 halves I get 9. That means we're going to need a 2. So I have x minus 1 squared equals 9 halves times y plus 2. This is the standard form. Now we want to find the vertex and the focus. Well, the vertex, that's pretty low-hanging fruit now. The vertex is going to be 1, -2. And of course I get that information just by grabbing these numbers and changing the signs. And the focus, now this parabola opens upward, right? It's a vertically oriented parabola, and P is positive, so I know it opens upward. And that means that the focus will have the same x-coordinate. I just have to figure out the y-coordinate. So from the standard form, I know that 4p is equal to 9 halves, and that means that P, if I divide by 4, P is equal to 9/8. So the focus, the x-coordinate is 1, the y-coordinate is -2 plus 9/8, because it's 9/8 units up from the vertex. So that's -2, that's -16/8 plus 9/8 is negative 7/8. So there's my focus.